You're in the Gemini spacecraft, and on the corner of the eye, you notice that your pressurant goes to 0. You have plenty of nitrogen and helium in the Gemini system, but you start to spin out of control. The thrusters won't work. You can't get to the pressurant, but you have plenty. You're going to die. What do you do? This program is brought to you by a great group of Patreon subscribers. Go to our Patreon page to read more. Join our Patreon supporters and get exclusive content and product discounts. In this issue, a spacecraft guide, we're going to dive into what happens when you lose control of the nitrogen pressurization system on the Gemini spacecraft, and you have to do something so you don't overpressure the system and blow it all apart. And that is with the OAMS Regulator Switch. And when you click on it, it takes you to the OAMS, or Orbital Orbit Attitude and Maneuvering System Regulator Switch. Now, what this switch does is it regulates the pressure manually by the crew of the Orbit Attitude and Maneuvering System and the reentry control system. So what this switch is going to do is it's actually going to take control manually of the nitrogen pressurization system. And if we look at general, we see here that the pressurant contains the high pressure helium stored at 3,000 psi. Okay, so the pressure from the pressurant tank is isolated from the remainder of the system normally closed pyrotechnic actuated isolation valve in the A package. Upon command, the system isolation valve is open. The helium flows through the E package to the pressure regulation, B package, and propellant tanks. So normally the propellant is controlled through the system pressure regulator, and regulator pressure flows through the B package. The B package serves as deliverant pressurant at the regulated pressure to the fuel oxidizer tanks, and that imposes pressure on the propellant tank bladder exteriors, which is going to push the propellants into the thrusters. And then here we go, relief valves of the B package pressurant overpressurization of the system downstream of the regulator. And then it has burst diagrams that provide a series of relief valves in package B to provide a positive leak type seal. Okay, so they have a package here. It prevents overpressurization. Well, when it protects the overpressurization system, you got to do something to be able to get that pressurant into the system, or you're stranded. So this, what it does is it shuts down the pressurant, and then the switch actually allows the astronauts to put pressure into the system to get the oxidizer and fuel to the thrusters. So now we're going to go back and we're going to go through the schematics. I'm going to show you where that switch is and how it works within the system for our Patreon subscribers, even our free Patreon subscribers. So if you're not a free Patreon subscriber, now would be a great time to join us and go through the schematics of how the astronauts would manually do the nitrogen pressurization. So when you click on schematics,